Good evening, everyone. I apologize for the delay. Let's see if this even works. Yeah, it should work. The delay was sponsored by, I guess, me upgrading to the newest version of Windows. What is it called? Like the Creators Update or something like that, which basically made my Linux virtual machine unusable and unbound all the devices like microphones and so on from open broadcast software, so I had to reconfigure it. And I obviously just realized that that's the problem 2 minutes before actually I should start streaming, so that's why the delay today. I have a good excuse today. That's my excuse, at least, that I have a good excuse. So again, sorry for the delay, and good evening, everyone. And yeah, today's moderator is disconnected. No, it's why do I have why isn't this flipped? Let's flip it. How do I flip it? Transform. Perfect. Now, yeah, this guy is today's moderator, and yeah, if you have any questions, then ping this guy on IRC or on YouTube, and he will telepathically let me know that there is a question, and I will try to answer it. Cool. So, what are we going to talk about today? We are going to talk about return-oriented programming, which is one of the classic, let's call it exploitation techniques. It's actually a bypass for the NX protection, which is the non-executable memory. It's quite funny because, if you know, for example, the executable format on Windows, you know, the PE format, then you know there were basically 3 flags for each section, always from Windows NT, from the beginning on Windows NT, and these were readable, writable, and executable. So you could set that the memory is, for example, readable and executable, or you could set it that it's only readable but not executable. And up until Windows XP Service Pack 2, these settings didn't do anything. Yeah. And you could execute any memory, regardless whether the executable bit was set or not. And then about that time, Intel introduced something called NX, which is again the non-execute memory, which is an additional flag bit in one of the variants of a page table, and actually the physical address extension page table, which isn't the most basic one, is the one on top of that, and this is related to 32 bits. The 64-bit page table already has the NX bit there. AMD, of course, did something similar. I think they called it execution disabled, XD bit or something like that, and Microsoft incorporated this as the DEP, data execution prevent mechanism in Windows. And obviously the similar story was happened on Linux. They quickly incorporated the NX bit, and it became effective, meaning that you couldn't no more put your shellcode on heap or on stack or wherever and just jump there and have it executed, because now the CPU would tell you, well, actually, no, this is readable, but it's not executable, so I'm going to throw an exception. And that killed that idea for exploits, basically, and then people realized that, hey, well, there's a lot of code in the memory anyway, right? I mean, there is the binary, the main binary of the process which is executing. There are countless libraries. Well, at least there's usually libc, a dynamic loader on Linux, and kernel 32 and NTDLL on Windows. And there's a lot of code there. Can we just find bits and pieces which we could reuse in memory and maybe just jump around a little and make the CPU do what it wants to do, what we want it to do? Anyway, regardless of us not being able to put our shellcode directly on the stack. And yeah, that plus, minus, or give or take, that's how ROP came into existence. Yeah, initially it was called return to libc, because you just returned to, for example, the system function in C. And then it became a little more advanced with actually not just returning to a single function or a chain of functions, but actually going to small pieces of code, which weren't really a function, just small pieces of code all around memory to do your bidding. So yeah, that's return-oriented programming. It's a pretty standard technique nowadays. Some might say that it's even deprecated a little recently due to additional protections being introduced, which are supposed to mitigate return-oriented programming. But I guess on CTFs is your daily bread and butter. You basically have to know return-oriented programming and to be able to exploit most challenges, if not all challenges. So I wanted to share some tips today with you on that. I'm not sure I'm going to be able to demonstrate all the things I wanted to show you because well, again, due to the Windows update, my Linux VMs don't work, and they totally don't work. And I wasn't able to debug it in 10 minutes before the stream, so yeah. So I guess I'll show you some of the Linux stuff, and I'll show you some of the Windows stuff more live. Cool. So before we get there, some usual announcements. No, this is the last announcement I want to make. So, okay, first of all, again, thank you to Disconnected for being here as my moderator. If you have any questions, then let him know. Disconnected.pl with a free here, that's a free, that's the address of his blog. I guess he updates it regularly, like somewhat. Yeah, there's a difference between frequently and regularly. Like, you can update something regularly even if you update it like every 6 months, but if you do it every 6 months, you still do it in a regular time periods, right? And you can do something frequently, like for example every 2 weeks or every week or every day. Anyway, thank you Disconnected for being here. Now, the usual set of my favorite YouTube channels being Live Overflow, which again, if you're into security, into CTFs, you probably know it already. If you don't, go there, subscribe. Live Overflow has really great video tutorials on security, basically. Then Mormos CTF is a new, well, somewhat new now. He's been streaming for a couple of weeks, mostly CTF stuff and security stuff. He streams in the US time zone, if I'm not mistaken, as in normally when I get an alert popping that he's currently going online, it's it's middle of the night, like 2 a.m. or something. So yeah, but check out his videos. He has some really cool stuff. For example, you asked about Manticore, which is, you know, like Anger-like thing. He did a tutorial on it, so check it out. It's youtube.com/mormusctf. Next one. Retro game mods. youtube.com/user/retro game mods. If you're into old computers and electronics, this guy is just awesome. And I really love his videos. He doesn't post too often, like once every couple of months, but they are usually really lengthy and really amazing. So yeah, totally go subscribe to his channel. Now some news. This weekend, or actually even before the weekend, Natalie, Natashenka, and Tavis dropped this tweet. I think Natashenka and I just discovered the worst Windows remote code execution in recent memory. This is crazy bad report on the way. Obviously it got, well, the hype was real, right? Everyone just started retweeting. And well, Microsoft actually released a patch a few days later, because the patch Tuesday was scheduled to be a few days later, and they responded really quickly to patching the problem. And it turned out that the problem is actually, and to show you how fast they responded, Tavis actually said is really an amazing response time, which I fully agree. Like a couple of days to fix a remote code execution of this scale, that's really well done. So Microsoft, like, nice, well done. The bug itself was kind of funny. It's basically a critical remote RCE in Defender, which is you know, the Microsoft's antivirus. I don't know the full details, but from what I know, it was a JavaScript scanner/interpreter. and it was in a either like in a critical process that had a lot of areas to access, or even in kernel mode, like something like with crazy high privileges. So the idea was that you just send an email that had some JavaScript with the exploit, and it would scan it for you and get exploited, and ta-da, you're there, you're on the victim's machine. So that was a really awesome bug that Natalie and Tavis discovered. So props to them and props to Microsoft for doing a really fast fix. Okay, so to close these, we can now chat a few seconds about, well, the solution to the second mission. If you're new to my channel or don't watch the videos until the end, until the very end, you should know that I post these like basic, simple challenges at the end of a stream. So when I actually go, you know, like turn off the camera, there's actually a mission in exactly this format posted, and you can basically read it and try to solve it, and then put a link to the solution in the comments under the video. I know some people, for example, on the Polish side of my podcast, some people do even full blog posts about how to solve it, and there are some really cool write-ups out there already. And a lot of people post codes of the solutions, which is also great. Thank you for sharing. And yeah, for the last mission, which was mission 002, was solved by 5 people. It was probably solved by more people, but 5 people did paste some codes under the video on YouTube on my channel. So quickly about the challenge this time. The challenge was that an agent got some message to send to the HQ, and it was Huffman encoded. So Huffman is a, well, it is hopefully it is a person, and basically there's something called Huffman encoding, and that's a compression algorithm, which boils down to creating, you have an alphabet and you create a binary tree where to basically the tree is usually created in a way that to the characters in the message, which are the least frequent, are actually somewhere at the bottom of the tree. This is the bottom of the tree, like furthest away from the root. And the characters which are really frequent in a message that you compress are somewhere close to the root, as close as possible. That's the usual idea behind creating a Huffman tree. Now, we are given a message which is basically ones and zeros, and this tree on the left, and you're supposed to decode the message. So usually in Huffman it goes like this, that if you have a tree, then going left is encoded by 1 and going right is encoded by 0, or the other way around. So going right is encoded by the opposite of what I just said, and going left the same. So in this case, for example, if we would like to encode the character, let's just go through the message, right? Let's assume that 1 is going right and 0 is going left, so that would be 1 and then 0, which would lead us to character 4. So after these two characters here, we would actually already emit the character 4 as the decompressed character, and then we had some zeros, so which means we would go left, 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 and I think there's like 3 ones after that, so 1, 2, 3, and that would be 9, so that would be 4, 9, and we already have the first ASCII character 49, which is I don't know, is like something like H-ish. So yeah, or maybe I think that's capital I. So that was basically the whole idea, but you had to transcribe this tree, figure out which characters are zeros and which are ones, and also does 1 mean going right or doesn't mean going left. So there are 2 possibilities to how to interpret this tree, and it was done like this on purpose. So you'd have to check both conditions basically. And yeah, the first one to submit a solution on the YouTube channel was Marek Zori. And the message, the encrypted message was, I like trees, flowers too. It was the correct answer. And he did post a link to his solution. He actually encoded the tree as a set of ifs. So he basically took the tree and converted it into a tree of decisional tree, basically based on ifs, which is a correct solution is somewhat lengthy in the way you write it down, right? It's like 50 lines and quite a lot of indentation, but in the end it worked. So yeah, you know, on CTFs, whatever works, works. And this is the same for such solutions. There are multiple ways to solve it, and it worked, it's a correct solution. Now, to get back to this, the second person who solved it was Artur Nowak. He also posted his code on GitHub. Now, he actually did transcribe the tree as zeros and ones. I guess he figured out or just tried which, what does 0 and what does 1 mean, like going left or right. And yeah, in the end, after transcribing the tree to zeros and 1, he basically decoded it by well, checking if the message starts with one of these, and if it would start, then he would add this to add the given character to the decoded message, and then would actually increase the position, the index which is used here by the length of well, how many zeros and ones were there in the given character. So quite a nice solution, well done. The third person was sorry, did I skip somebody? Yes. So the third person was Anonymous Mastos. I'm sorry if I totally butchered your name. And the implementation is on Pastebin. Now I actually can give you the link to this on both channels. So yeah, this is a public presentation. As in, you can actually click the links, you don't have to transcribe them. So looking at his solution, he basically has a really similar solution to the one I just told you. Again, he has a dictionary created with translation between the characters and a set of 0 and 1s. And then, yeah, basically, he does a similar thing to what I showed you in the previous solution. The fourth solution was done by Adrian Laskowski, which was posted on YouTube directly, and I really like the way he represented the tree. I must say that I would be super scared while writing this down not to confuse whether I opened enough brackets or closed enough brackets. I'm pretty sure he had it like written down in a long way and then just truncated it down, removing the spaces and new lines. But yeah, this is the final outcome, and I guess this is just walking through the tree until a character is found in it. So yeah, well done representing the tree as a set of recursive lists is, I guess, one way to go. Again, whatever works, works, and the code is rather short as well, thanks to this. It's actually, I think, one of the shortest solutions. And the last person was actually Arun Kumar, who posted a link. Again, that's on GitHub. And this is a similar solution. So again, it's a recursive set of lists. So actually a tree represented as a recursive set of lists, or like recursive list of lists, whatever. And basically the same code which goes from the root and traverses down the lists, which is a nice solution again, and a pretty short one at that. So yeah, these were the solutions to the previous mission, and the next mission will be obviously mission 003, will be posted at the end of this live stream. So that's that. Okay, let me quickly go through the questions, and we can go to we can start talking about return-oriented programming. So there's one question. Are you gonna do some Brehm? Brehm being blind Rob. It's from der Besserwisser. Is that like a person who knows better or something like that? I'm sorry, my German is terrible. At some point, yes, I would like to. Not today, but at some point I would totally like to. Blind Rob and blind exploitation is fun. it's not that I did it a lot, but it's fun. So at some point, basically, if you'd like me to do it, then put an idea for an episode in the comments under this video once it's on YouTube. And this is basically where I look for ideas for my videos. And today's episode is like that. I basically like found a comment which said, hey, do return-oriented programming, and I said, yeah, I actually feel like doing return-oriented programming today, so why not? There are 3 more questions. What's JOP? JOP is jump-oriented programming. It's somewhat similar in nature to return-oriented programming, but it's a little more complicated. Instead of returns, you're basically looking for jump switch tables in the code. There's a paper, if you look for jump-oriented programming, there's a cool paper about it. We can talk about it someday as well, so that looked like a cool technique. I never actually used it, I just read the paper. Okay, and there's one more question. Are those all challenges are going to be crypto-related? So der Besserwisser asks about the missions. Kinda, but no. Basically, they all will be programming related, as in, well, most of them. I will like the, well, you folks to basically solve the, do some programming in order to solve a challenge. That doesn't have to be crypto related all the time. It's, I would argue that Huffman wasn't really crypto related, it was a compression algorithm, so it's not really crypto, it's encoding, so that's more programming than crypto, I would argue. There might be some different ones. Today's mission will actually be similar to this one. And another question, are you going to Pixel Heaven at the end of this month? As far as I know, you don't despise retro games. I'm not going since I'm doing somewhat a break from the conferences this year. I attended one conference so far, and I'm going to attend another one late in the year, and that's about it. Maybe next year. I actually was thinking about going to Pixel Heaven, so yeah, maybe next week. Next year, sorry. Okay, let's get down to business then. So, well, I guess the most important part about, you know, ROPs and return-oriented programming is having a list of gadgets. And a gadget is basically a piece of code which ends with a return. Now, that's pretty obvious. I'm going to find some, I don't know, some library on the C. Since, again, I'm going to do Windows today, just because I don't have access to my Linux machine, I'm going to find NTDLL and kernel DLL. These are the 2 libraries which they are always in the memory of a process under Windows, always. You don't have to, the process doesn't have to have them in the import table, they will be there in memory anyway. That's how it works on Windows. So yeah, I have both these 2 DLLs, which contain quite a lot of code. If you actually look at them from something which can parse PE, there is the text section, which contains code, and it's executable, and it's readable, and it actually has a decent virtual size. That's actually quite a lot. I think it's over a megabyte of code, and you can usually find quite a lot of gadgets, as in usable pieces of code. A usable piece of code in return-oriented programming is called a gadget, if you didn't know. Now you know. So how do you extract gadgets from a file like that? There are a couple of ways. Usually you download a tool and use it, and there are some tools like ROP Gadget, I think one is called, I think is really popular. Personally, I'm using my own tool which I've written. It's clumsy, stupid, but it does its job, and it looks like this. It uses the Storm3 library for parsing the assembly. You have to set a lot of information manually in it, but then what it does, and it's actually it's quite short. I mean, it's 50 lines of code. Okay, so it's quite short. You know what? I'm going to change the font in I'm going to quickly change the font in my Vim because because I usually use a bigger font for streaming. Okay, now, so let's get back to checking what does it do. It has a main loop. It basically reads the file into memory, right? The whole file. And then starting at the offset which we given and ending at the offset which we given, it runs a function called decode asm, which is decode assembly. And it takes virtual address as one argument and basically 20 bytes of data. This can be adjusted as needed, but 20 bytes of data as the second argument. And now it CC is basically a list of instructions, or actually like the disassembled code, and there are some other things here which I won't go into. But it checks if the list contains a return instruction. It's called return-oriented programming because usually you need the return instruction to be at the end of your gadget. If the code does not contain a return instruction, it's probably not usable in your scenario for exploiting using return-oriented programming. There are exceptions, and I will mention them later. If it contains db something, which means one of the instructions was not really disassembled, it was not the disassembler thought that it's an invalid instruction, it cannot be disassembled, I just continue because I don't care about gadgets which contain illegal instructions. And then I check if it's unique, like the gadget which I found, is it unique? Did I find it ready? If not, then keep it. Yeah, and then I just print it out, as in print each instruction and the offset basically of it in a text form. I will show you. I'll run it in a second. I'll show you how it works. So the question is, what does the decode asm function do? And there is no sorry about that. There is no magic here. It just runs the disstorm3 disassembler and gets a list of instructions. Again, we are disassembling only 20 bytes, consecutive 20 bytes from the file, like first 20 bytes, second 20, well, not true. 20 bytes starting from offset 0, starting from offset 1, offset 2, offset 3. And by offset, I mean offset of the text sections, because we are usually focusing on the text section only, or any other executable section. It doesn't have to be the text section. And and then for each instruction, I just basically note down some stuff, and if I find a red instruction, I just stop there because red is always the last instruction, and return it, and that's it. That's everything you need to have in a gadget finder. I like my gadget finder because it's actually adjustable, as in if there is some crazy hard task on a CTF and I cannot find proper gadgets in the libraries I have in memory, I can just tweak it a little and look for maybe some other variants, because the ROP instruction, for example, could be represented by in assembly for something else. What it does, it gets the address from a return address from the stack and then jumps to it, right? So we could also do like pop EAX in 32 bits and jump EAX. This is an exact equivalent of the red instruction, except for that it actually destroys the EAX registers. So yeah, if it's needed, I could actually also add this to my code and look for these kind of instructions, and I sometimes do it. Now, let me show you how it actually works. I'm going to disassemble the ntdll file. Now, there's one more important thing to say about return-oriented programming. You do need the address in memory of some executable part of memory which you actually have. That's not the case for blind, where you don't need to have that piece of memory for blind ROP. You do need just to know where is it in memory. Now, ASLR, as in address space layout randomization, as in randomizing the place where the library is placed in memory. It could be placed here, it could be placed here, it could be placed here, you don't know. The address space is big, especially on 64-bit. That's one problem, and usually before you even get to ROP exploiting, you do need to get a leak of the address. So I'm assuming that you're already on a stage where Well, you do have the address, for example, of ntdll or libc or the main binary. So this is the ntdll, and what I need to note to actually run my app, it's the name of the executable, then the file offset start. I could actually read it from the P file. I started coding the new version of this tool, but I never finished it. And it does read it from the file. So what I need to do is I need to jump to the text section, and here this is the offset in the file. It's just 400. So I'm going to put 400 here, and now I'm going to Control S again and jump to the next section. The next section is actually also executable, so there might be some stuff which is, you can see here it's executable. There might be some stuff which I could use as gadgets as well, but I'm going to ignore it for now. Unless I'm really pressed for gadgets, I cannot find the gadgets I need, I just stick with the text section, like the main code section. I'm going to backtrack just to the boundary of the text and see at what offset of the file do I have this part, and this part is actually at this. Is it a correct file offset? I don't think this is a correct file offset. This is a correct file offset. So it's 10 dB 9F. I'm going to note it down here. 10 dB 9F. Okay, and now I need to basically tell it where does this file offset start, at what address does it start, because the way it calculates the address later is just adds the file offset to this. So I need to tell it where in memory is basically this, this section. So I just copy this address. Yeah, but I need to subtract the 400. Again, it's these 3 lines is actually something which all tools or decent tools do for you. You don't have to worry about it. I just do it manually because I don't care. And now I need to set the mode. This is 64-bit code. You can see that there are like a lot of 64-bit registers, right? So, so I'm going to leave it as this, and I can run it. I'm going to minimize this, open a console. And I'm going to do, first I need to switch to a Python version where I have, I think I have, sorry, the disassembler library installed. I don't have it on all versions, so I think this was the Python which actually has it. I'm going to run it, and it's going to, yeah, it's going to output a lot of stuff, so I'm going to save it to a file, ntdll.drop. I'll let it run, I'll look quickly on the questions and get back to it in a second. It usually takes about, I don't know, depending on the size of the library, actually, from anything between 10 seconds to a couple of minutes. And the longer it runs, the better, because it means you'll have more gadgets to choose from. Are there any questions? There are no questions, so I'm going to actually just open the file. If you have any questions, ping this guy on IRC chat or on the YouTube chat, and he will let me know about there are questions, basically. So, how does the output look like? It looks like this, basically. So, the first gadgets are obviously rather short. It's just the return instruction. This is the return instruction. There's also the return F instruction, which is return, but normally return only has the RIP or IP, right, which is the instruction pointer, but the F version also is return far, like return to a different segment. And while there are no segments in 64-bit, that is not fully true. You could actually use this instruction to change modes, like switch from 64-bit to 32-bit mode, though return F wouldn't work there. I think you have to have a prefix there, but you could totally use it to switch from the 32-bit mode to 64-bit mode. Now, yeah, so basically in RedDev, after IP, you have also the segment selector, which is usually like 16 bits only. But that doesn't matter now. Then there are a lot of weird instructions like this one, right? I'm terribly sorry about that. I'm still experimenting on how zooming works with this tool. Anyway, I just discovered today by accident that I can zoom in. This means that actually return and then add to ESP this value. This is useful in the std calling convention used under Windows. Well, maybe not with a huge value like this. This is probably some artifact, as in a set of bytes in memory, which aren't really a read instruction, are part of some other instruction, but you can interpret them as a read instruction and something else. So yeah, you basically want to stay away from anything which is follows read with a rather huge value, because this messes up your stack a lot. You don't want it. So by messes up the stack, I obviously mean it messes the stack pointer register. Okay, so now having this list, and it, as you can see, it finished. So I'm going to press F2 to reload it, and I'm going to open my pawn base. My pawn base is actually something where I do. Yeah, as you know, this is my base code. Something like I think it's called pawn tools, but it's short and it's written by me. It's something I use on the CTFs. You've seen me using it probably if you are watching my live stream for some time now. And the way I go about ROPs is I usually remove this and I create a function like gimme ROP. It's a pretty standard name. And let's assume that I'm writing a function, a ROP chain. You call a ROP exploit a ROP chain usually. For somebody else, it's quite common on like when we play with Dragon Sector that, for example, Mateusz Jurczyk does the full like finding a bug and exploitation until he can do the ROP chain, and then he asks me like, do the ROP chain for me, so we'll have the challenge finish earlier. So I just write this code and hand it to him, and it just creates the ROP chain. So I'm going to show you how I approach creating ROPs. Let's assume that the thing I need from the other person is the address of the NTDLL library, which is NTDLL in this case. And this is the address where NTDLL is placed in memory. Let's go like NTDLL base. Okay, and now the idea is here to return something which is a ROP chain. Let's call it ROP. Now, in most cases, for me, a ROP is actually a list, and but I need to return a string, right? Because you place on the stack. This is what you return here is placed on the stack of the process, and then the process basically goes does return to on it, like return on the first thing on it, and it returns to the address which is there. And again, there is a gadget which has another return, which returns to the next thing and next thing and next thing. That's why it's called a ROP chain. I'm going to, I guess, explain it a little better in a second. So yeah, so usually I have a list, therefore I do concatenate. This is Python 2, by the way. So I concatenate the list, and I have a couple of really important functions here, and this is emit a byte, emit a word, emit a D word, and emit a Q word or giant word, whatever you want to call it, a 64-bit word, basically, like a 64-bit unsigned integer, right? And I'm going to use this function a lot. It's just, you know, the standard struct.pack with Q as in Q word. So I give it a value and it emits 8 bytes, which are little endian encoded. This means little endian encoded 64-bit unsigned value. The capital Q means unsigned integer 64-bit. And this is the base of most of my exploits. Now, I don't really like writing the ROP chain in one function. I usually do it a different way. First, I take the bottom gadgets, which I need, and create separate functions from them. For example, I had usually a note here saying what's the Windows convention, but if I remember correctly, please correct me if I'm wrong, the Windows calling convention is RCX, RDX, R8, R9. I guess I'm going to check it. It's different on Linux, obviously. On 32 bits, it's even easier because you have all the arguments that go to a function on the stack. You don't need to pass them through the registers like in a fast call convention. On 64-bit, you do have to do it. It's a little different on Windows and on Linux. Now, again, where is my perfect wiki calling convention? Okay. And yeah, this one. So blah blah blah. Yeah, RCX, RDX, R8, R9, exactly as I said. A better document to actually look up the calling convention is Agner Fog calling conventions. This guy is awesome, by the way. I really like what he publishes in terms of these really useful tables about low-level stuff. And his calling conventions PDF is like super useful, and you can find this stuff here. There is a nice table, I think, on page 10, where for each different operating system, like 32-bit or 64-bit, it tells you where the parameters go, right? And yeah, they go here on Windows and they go here on Linux. And whatever doesn't fit here goes on the stack. So, but the stack layout on Windows is a little different, but let's not go there now. You basically just check how the calling convention works on Windows. Okay, so yes, I'm just noted down the calling convention, and what I usually need is I need basic gadgets to be able to set these registers. And please assume that during return-oriented programming, you assume that you have control of a stack. You have the RSP pointing to a buffer, which you control, right? So this is a buffer, a long buffer, which you control, and you can write stuff here. So the way you usually fill these registers is you, as the first item, so here, you put a gadget which does two things. It does, for example, pop ECX, sorry, RCX. It could be ECX, obviously, if you're if you don't care about the upper bits and you can set them to 0, and then read. And what it actually does is it's going to read the next variable and put it inside the ECX register, right? It's going to pop the next variable from the stack and put it inside the RCX register, and then it's going to take the next address and return to it. So you're going to have this point to another gadget in memory, which again does something, and does a read, which again will get some data from the stack, put it in some registers, let's say, and then yeah, jump to yet another gadget. This is the idea, that you find these gadgets in memory. So first what I do is I find gadgets which fill this basic register. So, well, I have to open my list again, and I'm going to look, Control F, to, let me maybe move it a little here. I'm going to look for pop RCX. And yeah, and this is the first gadget which comes, but it's not good. First is like return F. I could use it, but I would prefer something without this F here, so it's easier, so I don't have to put the segment there. Now this is some weird memory dereferencing, and if RBX is a wrong value, then it will actually crash my program. I don't really like it, and this is also destroying my AL, or actually RCX, RAX obviously, register. So I don't really like this gadget. I'm going to look further for something which ideally consists only of pop RCX and then read. So no. Maybe the last one, no. This is a little better. I could control 2 registers here, but there's also this one which actually eats 20 bytes of my stack. I don't like gadgets eating my stack, because sometimes the stack is limited. You have only, like, I don't know, 128 bytes where you can fit your rope chain in on the stack, because that's all you control. And well, if it eats 32 bytes of that, you don't have much left for other gadgets, right? And gadgets are quite space expensive on 64 bits. So no, I don't like it. I'm going to look further. No. Yeah, perfect. This is exactly what I was looking for. It's like one purpose only gadget. So now I copy this and I create a new function which I call set RCX. And it takes the new value of the RCX register. I usually keep this just as a reference, as a comment here. And now what I do is I do like something like this. I basically return a concatenated list, so it's basically a string. And now, first of all, I'm going to use the DQ here, which I mentioned, which emits a 8-byte, basically a 64-bit value. And I want to return to this address. Now, there's one more important thing. Due to ASLR, the NTDLL base is quite important here. So what I'm going to do is I'm going to basically take this NTDLL. I'm going to create a new value. Let's call it NTDLL. It's going to be none at this point. And sorry, it will be equal to, I'm going to set it here to NTDLL base, but minus the beginning of the base of NTDLL. Where's my IDA so I can check it actually? So if I scroll up, the base is image base here. I'm going to copy this value. Perfect. Yeah, because you know, with each gadget, I'm going to add this value, this huge image base here anyway, so that's why I need to subtract it here. And now, in each case, I can do NTDLL plus and the address of the gadget. This is the address of the gadget, the address of this instruction, right? And now, this is the return address, which basically brings me to this code, brings the CPU to this code, and now it starts executing. And first of all, it's going to look on the stack for the RCX instruction, so I need to put the RCX value here. Actually, since it's a string, I'm going to have to convert it to this value. And then it's going to look for a return address. Now, I do not put the return address here. This is something that the next instruction will handle. And now I do the same basically for RDX. So I'm going to look for pop RDX. If I'm lucky, it will be there. This is a decent gadget. It kind of spoils my AL register, but let's be honest, on Windows you usually don't need the AL register. But maybe there's a better one. So I'm going to look for it. Oh, this is a really nice gadget actually. If you look at it, it allows me to set, like starting from here, it allows me to set most of the registers. And yeah, I'm totally going to create a function based on it. It's quite expensive because even if I want to set only like R11 or R9, I have to put all these values on the stack. But on the other hand, it's quite useful, and there are a lot of functions on Windows which use a lot of parameters. So, but that being said, I guess like R10, R11, and racks are not going to be used yet. Let's take it. Set most, I guess, set most of registers. Racks, RDX, RCX, R8, R9, R10, R11. And I'm actually going to do default values here so that as a user I do not have to put all these. Yeah. So now I'm going to again copy paste it. As you can see, I'm going to use only part of the gadget which is on the list, but that doesn't matter, right? I mean, I can jump into any part of that gadget and that's still fine. And I'm going to do exactly the same thing as in first. I'm going to create this structure. Now the queue, return here, make the CPU return here, and now I need to put all these things on the stack, as in emit them in the byte stream and the rob chain. So yeah, I mean, there is no magic here, right? DQ RCX, DQ R8, DQ R9, DQ R10, and DQ R11. And let's assume that's yeah, that's actually all the things, all the registers I need for the calling convention. And I'm going to do a rather funny thing. I'm going to move this backward just so I have calling convention important registers in, I would like them to have the same order as is here. So I'm going to move this here. So it's RCX, RDX, R8, R9. Okay, so now I can call set most and just put 4 values, and these 4 values will be put in the correct registers, and the orders obviously kept here according to these instructions. So having these basic gadgets which set the registers is the first step I usually do. Now usually what you need in a ROP exploit is to be able to place a string in memory. So the next thing I do, I'm going to create a poke function. Poke, if you've been programming in 8-bit BASIC, you know that poke is a function which basically takes an address and takes a byte and pokes, like puts that byte inside on the address which you tell it to. So that's why I call it poke. You know, old habits die hard. Actually, 8-bit BASIC was the first programming language that I learned, and that was 27 years ago. Yeah, so really old habits. So address, and then maybe not byte, maybe V. I'm going to decide what V is in a second. Now I need to look for a gadget which actually writes into memory into a location specified by one register, and it puts a value specified by another register. So that's obviously when we look for stuff, I'm going to use regular expression search because that's like Lister from Total Commander actually has this option. You couldn't use grep. Grep, of course, has this option as well. So what I do is I look for move, and then I'm going to use these, you know, square brackets, right? Oh, I think I can actually do this. Yeah, perfect. But I need to escape it, and then there is a register, and then I'm closing this, and then there's another register. Dots, obviously, in regular expression represent anything. Now I'm going to look for it. Oops, this is not how you unzoom something. Let me do that again. Where did I? Yeah, here we are. The file actually contains 6 megabytes of opcodes, if you're wondering. Okay, so it found something like this. Like the address is RCX and R8D. It actually, the D here means it puts a 4-byte value. Ideally, I would like an 8-byte value. So I'm going to look again. No. This is probably the same gadget, like on the same address. This is a little better. It's a 64-bit value, as you can see. Both registers, like this register is 64-bit, so it means it writes a 64-bit value somewhere. But again, this messes up my stack and I don't like it, so I'm going to keep looking. I'm just on the, you know, 2% of my file. I have a lot of options, it seems. No, this would be good, but it's too high in before the return, too far from the return. No. Okay, so usually what I would do on the CTF, I wouldn't press F3 like that. I would take my console and I would use grep. I actually have grep on Windows due to GNU Win32 toolkit. And I can do something like this. I can look for the exact same thing which I just said, which is move. Then I need to escape this, R2 dots, space, and then R2 dots inside the ntdll .drop, and it doesn't like me for some reason. Alright, because on Windows you cannot use the single quotes, you have to use the double quotes. It does find a lot of stuff, but the way you use it normally is you give another argument, which is capital A2, which means display 2 lines after this. And what it does something like this. But now what I do is I pipe it to another grep, and I want to display 2 lines before, but what I grep for is actually the return address. And now what it finds all the instructions which, well, have 2 lines in this case, but I'm going to trim it down to 1 line. And yeah, and it displays all the gadgets which have this instruction, and it then, you know, displayed another line, and then it looked in these 2 lines for the return address, for the return instruction, and displayed the line above, which means it actually displayed only the lines which contain the move into a 64-bit address, a 64-bit value, exactly what I was looking for. I'm going to just use one of these gadgets, for example this one, because I already have it, my mouse cursor on it. So I'm going to fill my poke instruction, and I'm going to reuse the functions which I already created. So I'm not going to emit again using dequeue of these things. I'm just going to do return, and due to the way I actually construct this, like using this funny like a joint list of strings, I can just like do set most here. And what I need to set the RCX to the address. I'm going to type RCX equals address, because that's how well default values allow me to do. And I'm going to set rax to v. And that's it. I have already my poke. Well, not really, but I have my poke parameters set, but now I need to put this address on the stack so it actually returns here. So I'm going to do dequeue this address, and obviously I do need ntdll, and I don't know if I didn't forget the ntdl here. Obviously I did, so I'm going to add it here as well. Okay, perfect. So now I have my poke instruction. Now the next thing I like to do is actually to create a poke string instruction. So I'm going to do def poke string, like poke str, and an address and a string, right? And first of all, what I need to do is I need to make sure that the string length is divisible by 8, because I need values which are, you know, well, I'm going to use a 64-bit register to put the 64-bit value somewhere, and I'm going to put 64-bit parts of a string somewhere in memory, like wherever, right? So I need to make sure that the string is actually is the size of it is divisible by 8. So while length of a string is divided by 8 is not 0, it's not dividable by 8, then just add a null byte at the end. Yeah. So obviously there's a faster way to do it without using a loop, but I mean, I don't care. I'm going to run this code probably once to just generate the rob chain, and that's it, and maybe a couple of times, so it doesn't have to be fast. Having this done, I'm going to do something like this for I in range from 0 to length of the string, skipping every 8-byte chunks. Take the string and basically, so I'm going to do O is a list. I'm going to return obviously a joint list here. And I'm going to append a poke on the address of address plus I, because I is first 0, then 8, then 16, and then however the string is long, obviously. And what I'm going to put here is I'm going to put, you know, poke actually expects me to have a integer value here, but I have another convenience function which is called RQ, which is actually take a string, like this string, grab the first 8-byte and converts it to an integer. So it's like the opposite of what dequeue does. It uses unpack instead of pack, just that. So I'm going to use RQ string from I to I plus 8 is going to cut off the 8 bytes of a chunk, and that's it. And this is this function is going to put a string somewhere in memory. Now, once I have this, now I probably want to do something with it. And what do I want to do with it? On Linux, you usually want to run execve, or you want to put in memory the structure that allows you to run execve. On Linux, on Windows, you could do other stuff. You could either go for create process, or sometimes there's a nicer trick which is related to a function which is called load library. Now, I actually did not disassemble, I did not assume that I have load library here at all, but I'm going to check if I have load library exported here. Load library, okay. No, I thought the function is called a little different in NTDLL. Whatever, I'm going to assume, just for the sake of discussion, just for the sake of showing this to you, that I also have the address of kernel 32. I'm going to disassemble kernel 32 on my second monitor, and so far I'm going just to say that I have kernel 32 base address as well. This doesn't matter, it's just like a simple trick I want to show you. There are, you know, countless ways to actually do it. Yeah. And kernel 32 is going to be equal kernel 32 base minus, and it's already disassembled, so let's just look here, and I'm going to go at the beginning of the file. So yeah, the base address is the same image base basically, so I'm going to do this, and obviously I need to, I don't know if I need to, but I always like to create these global variables here anyway. And now I'm going to look basically for the load library A function, A being for ANSI, which means none. Otherwise, you know, the other option is W, which means it's a white character encoded in UTF-16 or older versions of Windows, but that's UCS 3. It doesn't like me for some reason. I know the function is here, but it's for some reason it's just called like load libraries tab, because, you know, in Windows 7, part of kernel 32 gets split into something called kernel base. So this library is probably in kernel base. No, it's even funnier. It's in this weird named library. But that doesn't matter at all. I can use this address, jump here, and this will jump me into load library. Now, what does load library do? Load library actually loads a DLL. How is that helpful if you're a remote attacker? I'll show you in a second. What I need now is I just need to have this like load library, and then we take a you know, a string, right? And that's it, actually. Yeah. So how do we go about it? We return again the same construct I've been using so far. First, we need to set the arguments, and the only argument is the string, but we need to put the string in memory. So we use the pokestring function, which I created earlier, and address. Now, the address is something like, where do we put it in memory? Well, where can we put a string in memory? And this is rather easy, because you just take, like, for example, in kernel 32, you jump into the data section, which is, oh, here. That's the data, I'm saying the data section because it's the only section which is actually writable, and we need a piece of memory which is probably unused and probably writable. I'm going to now jump at the end of this section, so I'm going to go to pdata and backtrace. Now, as you can see, there's a huge space between these two sections, right? The question is, what is in that space, right? Because in memory, you can have the memory split into pages. Now, each page is actually, well, that's not fully true, but usually each page is 4 kilobytes, right? So 4 kilobytes is actually 1000 in hexadecimal. So yeah, there is like one page here starting at A5000, and between this address here and between this address there is still a couple of bytes left, and it's not used by the library at all. And since it's not used, we can actually use this address as we can use this address as a place where we can store our strings. Or even better, I'm going to just use like A4F00. We have ideally like 256 bytes here where we can store anything. For example, strings, I'm just going to use that. So I'm going again to copy this. And this was, what was this library which I was looking for? No, that was kernel 32, so I need to use kernel 32 plus this address. Again, I said that I'm going to use F00, and I'm going to poke a string there, and the string is actually going to be the argument of load library. And now what I need to do is I need to actually set the registers, the first register of the calling convention, which again is RCX. Do I have a set RCX function? Yes, I do. So I'm going to call this function now. And remember that each of these functions actually return a string, so I can just concatenate these strings. So it looks like I'm actually programming, like writing a program right now calling functions normally. But that's not true. The functions are returning strings, but it doesn't matter for me because I look at it as a set of functions which are called one after the other, and that's the proper way to look at it. And I want to put here this exact address, right? This is where my string is going to be, and then I just need to jump into load library, which again is like kernel 32 plus OX and this address. And now I have a Python function created which actually does what does a lot of complicated stuff. It uses, like, you know, several gadgets which I defined or talked about today, but in the end when I create my rob chain is going to be load library, and this is the trick. This is my, let's assume this is my like IP address or something like Gynvael .pl, and it's actually a network name, and there's going to be an like evil DLL there. Because load library actually supports loading files over Samba, which is, you know, the Microsoft's file, like network file protocol. So I can load a library which is lying on my server, assuming that I have a Samba server there and that it doesn't need authentication to get into, which I can, obviously controlling the server, I can configure it in this way. And once it's loaded, the load library actually executes, well, first of all, it executes the TLS callbacks, if I remember correctly, but that's not important. What's important, it executes actually the DLL main inside that library. So what it does is going to fetch my backdoor from my server, which is a nicely compiled C file, into a DLL file, and it's going to run it. And this is my whole final ROP chain. And what I get at the end is I'm going to get, you know, a string. So let's just grab the string. I'm going to put some random addresses here so we can see how it's generated. That's way too much, sorry. And I'm going to encode it hex so we can actually see it in hexadecimal. Python pound base. Yeah, and this is the ROP chain in the end. Okay, so we can, I guess we could go through this ROP chain. What does it do again? Like basically slowly. Instead, I'm going to cheat a little today, and I'm going to do like add several prints, and the prints actually should be at the end of each function. So I'm going to do like this. Yeah, and I'm going to run it again, and it will show us the full ROP chain, basically. Okay, now this actually already does what I wanted to do, so print poke string and the address and the string. Now this one doesn't do, so let's can do this, return k, print poke v. I'm going to answer the questions in a second. Again, same story here, k equals return k. Set RCX and the parameter, and this is the last one. Set most, and then I'm going to like just print the registers, RDX. RCX, right. The values are obviously not going to be hexadecimal, but I don't care too much. Yeah, and now if I run it, this is my whole ROP chain in the order which it gets executed. As in, it sets some registers, then does a poke, sets some more registers, does a poke, sets more registers, does a poke, and this is actually writing the string into memory. Yeah, up until here. And this is actually the function which, this function is actually responsible for all of these, which is here. When it says the RCX, the same address as you can see here. This is the string we just put in memory. And then in the end, what we do is actually we do load library. And that's the whole ROP chain, which you can see here. So now I just like give basically the string, or actually I give this module, this Python module to whoever I'm working with, and I tell him, just run gimme ROP from this, and it will give you a nice thing which you put on the stack, and it does the exploit. Now, due to the way I actually structure this in a way which I showed you, as in I actually create for each gadget a function, and then create larger pieces like poke, and still larger, higher level pieces like poke string and load library. Due to the way I do it, it's really easy not to make any mistakes. It's really easy to... So it basically just works. Usually it works the first time, as in I gave it to somebody, the person runs it, and bam, we got a shell. So if I would be doing everything like each gadget as a separate line in this library, all the gadgets which I used here, or like several gadgets with quite a lot of arguments, it's quite easy to get it wrong. That's why I prefer to use this way of building higher level blocks, and finally just going for the exploit. So yeah, that's the best tip I can give you about return-oriented programming. It's obviously not the full extent of ROP, but it should get you started. Now, one thing about this method, I showed you that you can use load library, right? And it fetches a DLL from a remote server. Now, sadly, I don't have a test program which I could show you that it works. Maybe early next time if you like, or something. On CTFs, usually the application which you're exploiting on Windows is running in something called appjail, or like application jail or whatever is that called now, or appjail launcher or something like that. And this method doesn't work there. You couldn't go for load library. You would have to go probably for some create process or system. Just if you have MS CRT library like the Microsoft C library, then you can go for system and run whatever commands there. But you couldn't load a DLL of the server, which is sad, but yeah, that's the way it is on CTFs. Now on Linux there is a similar trick. It's actually called the magic gadget, and the magic gadget is do I have a C library? I'm going to find quickly a C library I have somewhere here on my disk from some CTF ideally. No. No. Okay, here's a C library, so I'm going to open it. I hope it's 64-bit. Yeah, and the magic gadget is basically you just use one ROP gadget, and if you're lucky, you're going to get a shell. And not a remote shell, but still a shell. You basically, it boils down to going to system, and inside the system, there's a do system, and inside here, there's actually, you know, all these setting up of the system, but at the end, there's some execv somewhere here. So, yeah, perfect. Now let's look for the execv, which I mentioned. I'm going to just decompile it to save some time. Where is the execv? Yes, so here's a clone. Is this what I was looking for? Let's see. Yeah, okay, here. Here's the... Basically what this block does, right? It puts sh and -c and the command for system. This is how system works. It calls bash -c and then just execv. Now, if you jump here or here, there is a really high probability that it will just run bin sh without any other parameters, and you'll just get a shell. And that's it. You just jump here, right, with ROP. Like, first return address you give this address, and you have a shell. If this doesn't work, and it sometimes doesn't work, try like jumping different addresses here, like in between. Sometimes it starts working, sometimes it doesn't. If it doesn't work, then you just go to the string to bin sh and do reverse lookup. And as you can see, this string is used in several places. One of them is, for example, like proc open or popen. You can jump there and basically see if you wouldn't have any luck here. For example, could you jump here to this line, and maybe this will actually allow you to get a shell. If this doesn't work, again, it basically depends on how the compiler for a given C library structures the code. But if you look around all these functions, there is quite a high probability that you will find a place that you jump there and you have a magic gadget, you have a shell, and that's it. So do remember about this trick. It's really useful on CTFs. It doesn't always work, obviously. So before I get to the questions, one more thing. If you actually go to my blog, I think I have a write-up on return oriented. Yeah, there's like my old 2009 post called Return Oriented Exploiting, and I'll give you a link on both channels. And you can read it. It's basically what I've told you today. There's also some nice, well, semi-nice graphs which might make it easier for you to understand if you didn't get what I'm talking about today. Just read through it. There are other tutorials on return-oriented programming as well, so take a look at that. One more thing to remember, which is, I guess, more trivia than really useful, is that return-oriented programming is actually Turing complete. What that means is that you can actually have conditional jumps in return-oriented programming, and you can have loops which jump backward. And actually, like, I think 2 years ago for a CTF, I created a challenge which was a crack me, which actually was a just a shell code of ROP. The program was nothing else than just copy this on the stack and return there. And then the ROP chain was executing what was a virtual machine, an implementation of virtual machine, which actually the KrzaQ was implemented in the bytecode for that virtual machine, which was again implemented in a ROP chain. I have that KrzaQ somewhere lying around. If you're interested, then ping me. I'll send you it. So you can do tricks like that in ROP as well. Okay, now let's go to the questions and let's round it up for today. Now, the address Gynvael is putting in the address contains null bytes. Won't this cause the program to stop reading? This is an excellent question because it's a common misconception. The null bytes are important only if you are reading using the F function, which was created to read to operate on ASCII strings, ASCII Z strings, which means like C strings which have a null terminator at the end. And this is like scanf, gets, or fgets. But on CTFs, usually what you deal with is read or resv, like receive, right? And neither of these functions operate on strings. They both operate on bytes, which means you don't care about null bytes. Null bytes are not a problem for you. They just work. And usually when you create a ROP, you don't care about null bytes. Most of the stuff you exploit are not ASCII Z overflows, are just byte overflows. So sometimes this question is valid, but you have to care about the null bytes because they just will stop you from like reading stuff. Other times, if it's a read or a receive function, you just don't care about them because they will just work. Now, one total random tip is that even if you have like fgets, which actually fgets actually does care about the null byte and reads until the null byte, or does it? Maybe I'm lying now. Actually check. I know that fgets reads until the end of the line, but maybe it reads through the null bytes as well. I would have to check it. For the sake of the discussion, let's assume that you have, I don't know, some string copy which actually does care about the null byte. Or actually some variant of fgets which actually does care about the null byte. Do keep in mind that fgets actually calls read in the end, and read actually reads a whole block at the same time. Even if fgets you try to read 1 byte, the read underneath will still attempt to read 1 kilobyte or a couple of kilobytes of data depending on the implementation and put it somewhere in the buffer in memory. And if you're lucky, you can basically get the address of that buffer and jump there and like do a stack pivot, which is something I didn't talk about today. But yeah, there is, even if it didn't read into the destination buffer, everything, it did place it somewhere in memory, unless it's, not buffered or anything like that. Cool. Next question. Can't larger pages be requested with virtual alloc? That's correct. That's why I said that pages are usually 4 kilobytes. Larger pages like, I think like 1 megabyte or 2 megabyte or like 16 megabyte or 1 gigabyte, depending on the operating system and which mode you are in and what set of page tables you're using. Yeah, these kind of pages can be requested and they're sometimes useful as well. But usually you just operate on 4 kilobyte pages. Can you show example which does something? So unfortunately not today, since I guess we're short on time right now. I don't have an English video with return-oriented programming. I can try to show you maybe next time if you're interested. Like, let me know in the comments under this video if you're interested in seeing actually how this program which I created, this exploit which I created today, working. Because I can create a demo program for this, but it actually would be exploitable, but maybe not today, as it's already a little late. But let me know if you're interested in seeing it. I can like make it ready for the next stream. Can you load an exe with a load library? Yeah, basically yes. It's I think you can. I'm not sure if main is then executed on the same way as as the DLL main is executed. But that doesn't matter in the end, because you know you can always create a DLL file which has a DLL main file, which is basically the same thing, which like the main function or winMain in an executable. So it doesn't really matter that it's a dynamic library. There is still a function which will be called as soon as the DLL is loaded, where you can place your code, which does some like backdooring and so on. Okay, I guess that's it for questions today. Now, there won't be any stream next week. I apologize for that, but there's the Confidence Dragon Sector CTF, and also I have some other stuff on that week. Therefore, I just won't be able to make a stream. So there will be a stream in two weeks, obviously. So that's it. Thank you for being here today. Thank you to Disconnected, who actually was the moderator today and helped me a lot with it. I will upload my Pwnbase and RobG scripts to GitHub, to my GitHub. There's the stream en directory there, so you can take a look what I coded today. And yeah, and see you in 2 weeks. So if you have any questions, then let me know. And stay tuned for the mission, which is just after, well, we'll show just after I finish talking, basically. So again, thank you to Disconnected, and thank you to all of you for being here. If you like the stream, then let your friends know. The more, the merrier. So that's it. Yeah, happy hacking. See you. Bye-bye. And see you in 2 weeks.